All right, so let's look at some examples here. So here we have the rate of change of the population of a country in thousands of people per year is modeled by the function f with input t, where t is the number of years since 2005. What are the units of measure for? And the area of the region between the graph of f and the t-axis from 0 to 10. B is the integral from 10 to 20 of f of t dt. And then c is the change in the population from 2005 through 2010. So let's think about this. For first, let's look at that first one, the area of the graph. Well, if this is in 1,000 people per year, and this is in years, if we take 1,000 people per year times years, then for A, what we have, well, area is going to be equal to 1,000 people per year times years. And so that's just going to be 1,000 of people. Okay. So that's going to be how that one works. So A's units are going to be 1,000 people. Now B, what is that going to be? Well, here we're taking the integral from 10 to 20 of f of t dt. So let's write this down. So we're going from 10 to 20 f of t dt. Well, what we're going to have is you're going to units for f times units of t. Well, what's that be? Well, that's going to be the same thing we just did here. Units of f times units of t is what's going to come out. And so that's going to be 1,000 people again. Okay. Now, what's the change in the population from 2005 to 2010? Well, here we're going to have the change in population. And that's going to be our unit of the rate of change times the unit interval. I can write here. And unit the rate of change said it's in 1,000 people per year. Times unit interval is here. And again, we get 1,000 people. Okay. And so that's going to be basically kind of showing you that they all come back with our same units, basically. All right, what about the next one? When warm water is released into a river from a source such as a power plant, the increased temperature of the water causes some algae to grow and other algae to die. In particular, blue-green algae that can be toxic to some aquatic life thrive. Now, if G of T organisms per hour per degree Celsius is the growth rate of blue-green algae, and T is the temperature of the water in degrees Celsius, what do the following represent? All right, so for A, if we think about that, that's going to be basically what do the following represent? Okay, so this A is going to be, it's going to be the change in growth rate of blue-green algae in a river as temperature of the water increases from 25 to 35 degrees C. Probably should put the C there too. Okay, so it's increasing from 25 degrees Celsius to 35 degrees Celsius. All right. So basically, it's going to be the number of organisms per hour, because we're going to take it times the temperature, and we're going to just get the number of organisms per hour is going to be our growth rate, basically. Okay. Now, what does B say? The area of the region between the graph of G and the t-axis from 30 degrees C to 40 degrees C. So it's going to be a change in growth rate. Of our blue-green algae again in a river as temperature of water increases from 30 degrees C to 40 degrees C, okay? So both of them are representing our change in growth of our blue-green algae in the river as a change in, and this one, it's a definite integral, so it gives us definite values from 25 degrees to 35 degrees C. And this one says, well, it's going to be the area of the region under the graph. And again, with that integral, what it's doing is it's going to find the area under the graph. So it's going to actually give us that. And the area of the region between the graph and the axis, well, that's going to be the same thing. It's going to give us that change in growth rate, okay? All right, so let's stop there and we'll come back for starting our long type of problems.